Hello, today we have a few topics on using determinants to solve different problems in linear algebra. So the first is a Cramer's rule. So we can solve a linear system of equations using determinants only. So what we do is we select our matrix A, which is given in a task, and then we calculate its determinant. So in case the determinant is not equal to 0, we have one solution to this problem. So how to find this solution? We will take our matrix A and replace the if column with vector B. So the rest will be the matrix A, but we substitute, instead of column I, we substitute B. And after we do this, we calculate the determinant of this matrix. Then we divide this determinant by the determinant of initial matrix, and that's how we get the answer. That's how we get the respectful xi. Also, there is a formula to find the inverse matrix by calculating the adjacent matrix. Adjoint using the substitution of vectors B that are just the column where everything is equal to 0 except for the element I where it is equal to 1. But we will show it later. Okay. So let's solve the first problem where we have the system and we need to find the solution to it. So the matrix A is equal to 2, 3, 0, 0, 4, 5, 6, 0, 7. So let's find the determinant of this matrix. In order to do this, we can use different approaches, but we can just use the formula of the determinant because there are many zeros already. So the formula tells us 2 times 4 times 7, then plus 6 times 3 times 5, then plus 0 times 0 times 0, minus 0 times 4 times 6, minus 0 times 2 times 5, and minus 0 times 3 times 7. So we have only two meaningful components. 2 times 4 is 8, 8 times 7 is 56. And then we have 6 times 3 times 5. 3 times 5 is 15. 15 times 6 is 90. And the sum is 146. Now let's calculate the substitution. So we will calculate when we substitute vector B instead of the column 1. So we will get the matrix. Instead of 206, we will have 8, 3, minus 1, because this is the B vector. This is the B vector. And the rest of the columns will be the same. 3, 4, 0, 0, 5, 7. So now we calculate the determinant of this matrix. So in order to do this, we can, for example, add the last row to the first row multiplied by 8. So I will get 0, 3, 8 times 7, 56. Then here I will have 3, 4, 5, which is not changed. and minus 107, which is also not changed. Then I, for example, can add 3 times the first element of the third row to the first element of the second row to get this element to be equal to 0. So I just multiplied the whole row. I will get 0, 3, 56, 0, 4, 3 times 1 is 1 times 7 is 21. 21 plus 5 is 26. Here we have minus 1, 0, 7. So this determinant can be calculated using cofactors. So I will place minus 1, this value, then times minus 1 to the power of sum of the number of row. So the row is number 3, and the number of column, which is 1, the first column, and times the remaining determinant, which is 3, 56, 4, 26. So we eliminated the first column and the third row, and the remaining is that. So minus 1 to the power 4 will be plus, times minus 1 will be minus 3 times 26, minus 4 times 56. So when we calculate this, we will get 292. Divided by 2, which is 146. Next, let's substitute B instead of second column, and let's calculate the determinant. So it will be the first column of matrix A, 206, the B, 8, 3, minus 1, and the third column of matrix A, 0, 5, 7. So in order to calculate this thing, we can, for example, subtract the first row times 3 from the third row. We'll get 2, 8, 0, 0, 3, 5. 6 minus 3 times 2 is 0. 3 times 8 will be 24. Minus 1 minus 24 will be minus 25. And 7 minus 3 times 0 will be 7. So now I can use cofactors again. 2 times minus 1 to the power of the sum of the row 1 and the column 1 times the remaining determinant. So I'll have minus 1 to the power of 2 will be plus, will be 2 times 3 times 7 minus 25 times 5. So it will be 2 times 27 plus 125. So it's 2 times 146. Now I can calculate the determinant when I substitute D instead of the third column in matrix A. So the first column will be 206, second column 340, and the third column will be 8, 3 minus 1, which is B. So here I can just use the formula. 2 times 4 times minus 1 plus 6 times 3 times 3 plus 8 times 0 times 0 minus 8 times 4 times 6, then minus 0 times 3 times minus 1, and minus 2 times 3 times 0. So there are only 3 meaningful terms, and their sum will be negative 146. So now I can calculate x, y, and z. So x will be the determinant when I substituted column B in the matrix A by the determinant of matrix A. So it was 146 divided by 146, which is 1. So y is the determinant A when we substituted B instead of the second column, divided by the determinant of A. So it will be 2 times 146 divided by 146, which is 2. And Z is the determinant when we substituted column B instead of the third column of the matrix A, divided by the determinant of matrix A, which is negative 146 divided by 146, which is minus 1. So we solved the first problem. The next problem is to find the classical adjoint of matrix A. So we want to find the inverse matrix, and in order to do this, we want to find the adjoint of matrix A. So what is the adjoint? So we want to replace the first column with 1, 0, 0. The second column with 0, 1, 0. And the third column with 0, 1, 1. And then we can solve what will be the values of x, y, z. So we can multiply our matrix and get those vectors. And those vectors will give us the identity matrix size 3. So let's start first with the first one. The determinant of A, we usually do this, otherwise, if we don't check for the determinant and it is equal to 0, we cannot find the inverse matrix because there is nothing to divide it. But to calculate this, we will subtract the first row from the second and the third rows. So we'll get 1, 1, 1, 0, 1, 2, 0, 5, 5. Now I can subtract the second row times 5 from the third row, and I will get 1, 1, 1, 0, 1, 2, 0, 0, and 5 minus 10 is minus 5. So the determinant of the triangular matrix, and we have the upper triangular matrix, is just the multiplication of diagonal elements, which is minus 5. Next, we can calculate the adjoint of our matrix. So we will replace the first column with 1, 0, 0. Which is 2, 3, 6, 6. And when I calculated this thing using cofactors, this will be 2 times 6 minus 3 times 6, 12 minus 18 minus 6. So we found the first element. Now we substitute 1, 0, 0 instead of the second column. So here I will use cofactors, 1 times minus 1. So it is the first row, but the second column times the remaining determinant. So it will be negative 6 minus 3, which is minus 3. Now I substitute our 1, 0, 0 instead of the third column. So it will be 1 times minus 1 to the power the first row and the third column. 1, 2, 1, 6. So it will be plus 6 minus 2, which is 4. So these are the numbers in the first column. So the numbers are minus 6, minus 3, and 4. And the matrix has the determinant of negative 5. So we will divide this by 1 divided by -5 times this matrix will give us the inverse matrix, but the matrix itself is a joint matrix. So we will try to find it. Okay, so now we will go to the next column of identity matrix. So we will replace each of the columns using 0, 1, 0. So I will have 0, 1, 0, 1, 1, 2, 3, 6, 6. And I need to find this determinant. So it will be 1 times -1, second row, first column, times 1, 1, 6, 6. So 6 minus 6 is 0. Next, 1, 1, 1, 0, 1, 0, 1, 3, 6. So it will be 1 times -1. This number is in the second row and second column, times 1, 1, 1, 6. So it will be 6 minus 1, which is 5. And then 1, 1, 1, 1, 2, 6, 0, 1, 0. So we will select again this 1. 1 times -1 to the power of second row, third column, times the remaining determinant, which is the same as the previous one, but -5 will be the answer, because here we have 2 plus 3 is 5, and -1 to the 5th power will be negative. Now we found the next column, so it is 0, 5, and -5. Now we need to find the last column, so we will input the third column of identity matrix, 0, 0, 1, 1, 1, 2, 3, 6, 6. So we will use cofactors. 1 times -1, third row, first column, 1, 1, 2, 3. So 1 times 3 minus 1 times 2, which is 1. 3 plus 1 is 4, so it's just 1. Next, 1, 1, 1, 0, 0, 1, 1, 3, 6. So we again use this as base for our cofactors. This is the third row and second column. We have 1, 1, 1, 3, and it will give us negative number. 3 minus 1 is 2. And the last 1, 1, 1, 1, 2, 6, 0, 0, 1. So again, using cofactors, 3 plus 3, 1, 1, 1, 2, 2 minus 1 is 1, we will get 1. So the last column of our adjoint is 1 minus 2, 1. And that's the end. So if I multiply this matrix by -1 divided by 5, I will get the inverse matrix of the matrix A.